Ever wondered what happens when a star dies? Ever pondered the mysteries of the cosmic abyss? Today, we're diving into one of the universe's most intriguing phenomena, black holes. These celestial behemoths, born from the death of massive stars, have long captivated our curiosity and sparked countless questions. How are they formed? What role do they play in the cosmos? And what could possibly exist beyond their event horizons? Prepare for a journey to the edge of the universe as we explore the enigmatic world of black holes. So, what exactly are these mysterious cosmic entities known as black holes? Well, imagine a celestial object with a gravitational pull so intense that nothing, not even light, can escape from it. That's a black hole for you. They are regions in space where gravity is so strong that everything nearby gets sucked in. But don't worry, they're not lurking around every corner in space. Black holes are formed when massive stars collapse under their own gravity after burning through all their fuel. Now, there are different types of black holes. Stellar black holes are formed from stars several times larger than our Sun, while supermassive black holes are millions or even billions of times more massive than our Sun. Supermassive black holes are often found at the center of galaxies, including our own Milky Way. One of the most intriguing features of a black hole is the event horizon, the point of no return. Anything that crosses this boundary will be forever lost to the black hole's insatiable hunger. Despite their ominous name and reputation, black holes play a crucial role in the universe. They help in the formation of galaxies and influence the path of stars. They are the ultimate recyclers, breaking down matter and releasing it back into the universe in a new form. Black holes, the ultimate cosmic vacuum cleaners, are truly fascinating, aren't they? To understand black holes, we must first understand the life cycle of stars. Stars are born in nebulae, vast clouds of dust and gas. The force of gravity pulls these elements together until a protostar forms. As this protostar accumulates more mass, its core temperature rises, initiating nuclear fusion. This marks the birth of a star. The star then spends the majority of its life in a stable phase known as the main sequence, where it continually fuses hydrogen into helium. The size of the star determines how long this phase lasts. Larger stars burn through their fuel much faster than smaller ones. Eventually, the star exhausts its hydrogen supply. What happens next depends on the star's mass. Stars similar in size to our Sun become red giants, shedding their outer layers and leaving behind a white dwarf. But for more massive stars, the story is dramatically different. These colossal stars become supergiants and undergo a series of nuclear reactions, producing heavier elements. When the fusion process can no longer sustain the star, it collapses under its own gravity, leading to a supernova explosion. The core that remains after this cataclysmic event can form a neutron star, or if massive enough, it collapses further to form a black hole. And so, from the remnants of a massive star, a black hole is born. Now that we know how a black hole is born, let's dive into the mind-boggling properties of these cosmic entities. Black holes are not just cosmic vacuum cleaners hoovering up everything in their path. They're far more complex and intriguing. One of the defining characteristics of black holes is their immense gravitational pull. This gravity is so strong that nothing, not even light, can escape once it crosses the event horizon, the boundary of the black hole. This gravitational pull is responsible for an extraordinary feature of black holes, the warping of space-time. Einstein's theory of general relativity tells us that mass and energy cause space-time to curve. Black holes, being extremely massive and compact, cause an extreme curvature, creating a well in the fabric of space-time from which nothing can climb out. Inside this well, at the very heart of the black hole, lies the singularity. This is where the laws of physics as we understand them break down. All the mass of a black hole is concentrated into this infinitesimally small point, creating an almost infinite density. The singularity is hidden within the event horizon, making it impossible for us to see or study directly. The size of a black hole, defined by its event horizon, is determined by the Schwarzschild radius. This is the radius that if all the mass of an object were to be compressed within, the escape speed would equal the speed of light. For a black hole, the Schwarzschild radius becomes the radius of the event horizon. Finally, let's consider the effects of approaching a black hole. As you near the event horizon, the gravitational pull becomes so strong that time itself begins to slow down. This is known as time dilation, another prediction of Einstein's relativity. As we can see, the properties of black holes are as fascinating as they are mystifying. Black holes are elusive, but not completely invisible to our scientific instruments. In fact, their detection is largely indirect, and it requires a keen eye and advanced technology. So how exactly do we detect these cosmic monsters? Well, black holes can't be seen through traditional optical telescopes, but they do leave observable traces. One such trace is X-ray emissions. When matter is drawn into a black hole, it forms a swirling disk around the black hole known as an accretion disk. As the matter in the disk spirals inwards and heats up, it emits high-energy X-rays that can be detected and studied by X-ray observatories. Another groundbreaking method of detecting black holes is through the observation of gravitational waves. These are ripples in the fabric of space-time caused by the acceleration of massive objects like merging black holes. The detection of these waves has opened up a completely new way to study the universe and its most elusive elements. Telescopes and space missions also play a crucial role in black hole research. For instance, the Event Horizon Telescope, a global network of radio telescopes, produced the first ever image of a black hole in 2019, marking a significant milestone in our understanding of these cosmic enigmas. With every new discovery, we inch closer to understanding these mysterious cosmic phenomena. So there you have it, a journey to the edge of the universe and into the heart of a black hole. We've delved into the formation, unique properties, and detection methods of these cosmic enigmas, not forgetting their significant role in the universe. These celestial phenomena continue to challenge and expand our knowledge, captivating our imagination. As we continue to unravel the mysteries of the universe, who knows what we'll discover next?